Welcome to the final round of your Google software engineering interview. We're prepared to offer you as a new grad a compensation close to $200,000. But first, we need you to answer this last question as part of your final round interview. We want you to solve the LeetCode problem, count battleships on a board. You're given a 2D matrix of characters, either X for battleship segments or periods for water. Ships can only be placed horizontally or vertically, and they can never touch on the diagonal. Your task is to count the number of distinct battleships. What's your first thought? I'm gonna iterate through that matrix, and whenever I find an X that I haven't visited yet, I'm gonna run a BFS algorithm out from that X, marking each X visited as I go, and then count the ship at the end of that BFS call. Walk me through that. I'll scan every cell. If I see an X that isn't visited, I also explore all adjacent X cells that aren't visited. Up, down, left, and right. Mark these visited as I go, and then just add them to the queue. After the BFS finishes, that's one full battleship. And the runtime? We visit every cell exactly once, so it's a linear time algorithm. However, our BFS is using a queue and a set, which costs extra memory. It works, but I'm thinking I might actually not need all that extra space. Since ships are only placed horizontally or vertically, and they never touch diagonally, is there a way to count them without exploring every part of the ship? Oh, instead of traversing each ship, we can just detect the start of a new ship. Explain that approach. We're gonna scan through the array again, and when we encounter any X, either the starting cell of a ship or a continuation of a ship that began above it or to the left of it. So for each X, we just check two neighbors. If there's an X above it, it's part of a vertical ship. Skip it. If there's an X to the left of it, it's part of a horizontal ship. Skip it. If neither of those conditions are true, this cell must be a top left corner of a new battleship. So we simply increment our count. How about the runtime here? It's a single pass, O of m times n time. However, with this approach, we use O of 1 extra space. Much cleaner. We just needed to read the problem a little closer. Perfect, you got the job. I'm making a video like this each and every day to help you improve your pattern recognition for software engineering interviews. If you found this video helpful, consider dropping me a follow. I'll see you tomorrow.